Now we'll return to finding sample sizes for a specific example. In this example, the internet is affecting us in many different ways. So there are many reasons for estimating the proportion of adults who use it. So this example is looking at the proportion of adults who use the internet, estimating. So we should right away be thinking about p-hat. We're not talking about means. We're talking about the proportion of people who use the internet, not the mean number, something like that. So assume that a manager for eBay wants to determine the current percentage of U.S. adults who now use the internet. The question is, how many adults must be surveyed? So here is our question. We are trying to find N, and it's involving sample proportions, right? So in order to be, and then we have more information that we're going to need, we've got a 95% confidence that the sample percentage is in error by no more than 3 percentage points. So here we've got our confidence level. We've got to pull all these things. And notice I just do it right as I work through the problem. I just keep pulling them out. So the confidence level is 0.95, and the error, or margin of error, capital E, is no more than 3 percentage points, or 3 over 100%. So 0.03. And hopefully now we've got plenty of information to check on our formula page and solve the problem. So in 2006, we've got two different situations. In 2006, it says that 73% of adults used the internet. So in other words, in this example, we actually know what p-hat is. This is our p-hat. So we can jot that one down as well. And then let's just write the formula and work it out. So remember, N is equal to the critical value squared times p-hat times q-hat all over the margin of error squared. Now if p-hat is 0.73, that means that q-hat is 1 minus that, so, or the complement, which is 0.27. And for a confidence level of 95%, we know that the corresponding critical value for that, we can pull that right off of our z-score table. Whoops, is 1.96. So we're going to square the critical value and then multiply it by p-hat and q-hat all over our 3 percentage points squared. And when I worked this out, feel free to pause this at any time and work it out for yourself, but I got 841.3104, or in other words, I found that N was equal to 842 is the number of adults that we must survey. So here, let's maybe write this down. So to be 95% confident that our sample percentage is within 3 percentage points of the true percentage for all adults we should obtain a sample of at least 842 adults. Good. This should be a W-E-W, not a W-H-E-W. Good. So we need at least 842 adults to have a confidence level of 95% and a margin of error within 3 percentage points. And this is going to vary, though, for part B. So what if, instead of p-hat being known, the sample proportion being known, or assumed to be 0.73, what if it's just not known? And again, that's the case where we're going to have to estimate what is p hat and q hat. If they're unknown, remember they're just 0.5. And then we can solve this once again the exact same way. Write the formula. Again, it's just good habit that every time we use a formula to write it out, we're going to square the critical value, multiply by 0.25 if we want, or you could show it as p hat times q hat, but again, in this situation, it'll always be 0.25, and our margin of error squared. And so when we recalculate, we see that that's going to change our calculations a bit. And in this situation, our rationale would be the same. We need at least 1,068 adults to be within 3 percentage points at a 95% confidence level.